Okay, so this is number 6. We're going to turn to page 3. This is kind of the last big kahuna, and this is kind of new stuff. This will be mathematical. The study I'm going to describe for you is actually in case study 3, so let me share it with you. Have you ever heard of the Loftus and Palmer experiment, the car accident thing? Have I talked to you about this at all?
I don't think so.
And Beverly, have you ever heard of this car accident experiment type thing?
Yeah, I think we talked about it in social psychology.
Yeah, it would be a social psych. Emily's had it with me because she's my daughter a couple of times, but let me set it up for you.
I haven't had social psychology.
Yep, but I talked to you about the study. So, very simple study. People were in a room, and this is back in 1974 when video equipment was not like all over the place. So they came into a room and they had people watch a car accident. So they watched a car accident, and then they had maybe different groups, and everybody saw the same car accident, but then after they saw the car accident, people in one group would read a sentence that would say, how fast were the cars going when they, and in one group, it would say, made contact. And then they gave the speed estimate. People in a second group, they would see the same car accident, and then they would see a question, how fast were the cars going when they bumped? And they would give their speed estimate. And the people in the third group, how fast were the cars going when they smashed? And Emily made a good point in my outline here. I put crashed. Crash, smash, same idea on the bottom of the multiple comparison. Sorry about that, but smashed is good. So the question is, if you watch an event and the event is the same for everyone, how should that memory actually be? How should your speed estimate actually be if everybody saw the same accident?
Similar?
It should be kind of similar. Yeah. Beverly, you're thinking the same thing?
Mm-hmm.
Yeah, it should be similar. But in this very famous experiment, they changed the wording. So what is the independent variable here?
Wording.
It is the wording. The wording was manipulated. So the variable that is manipulated is the independent variable. It's the wording. So in this case, the independent variable is the wording. What is the dependent variable, Beverly?
The speed that the participants was worded.
The speed estimates. So you should know independent variable, independent variable. Could we actually do a t-test on this? Could we do one t-test on this? Beverly, what do you think? Could you just do one t-test on this?
Well, it's got 3 levels.
Yeah, you have 3 levels. So if you were going to do a t-test, you'd actually have to do a couple of different t-tests. You'd have to compare group 1 to 2, 2 to 3, and 1 to 3. So a t-test you only do with 1 independent variable and 2 levels. How many levels do I have here?
3.
You have 1 independent variable. If you want to write down, this has 1 independent variable and 3 levels. The 3 levels are what? So your 1 independent variable is wording. Emily, what are your 3 levels?
Made contact, bumped, and smashed.
Yep,
slash crash.
made contact, bumped, and smashed. So you have 1 independent variable and 3 levels. And so
It's all crashed down at the bottom.
sorry, I crashed and burned. So you have 1 independent variable and 3 levels here. And so if you look, I put the data in there. You have a total of, is this an independent sample or is this a repeated measures design?
Repeated measures.
Why do you say repeated measures?
Because you did it more than
I did do it more than once, but how many times were people,
they only had to do it once.
the participants were only in one condition. They were only tested once. Independent samples is you're only tested once.
Okay.
So it's how much data I collect from the subjects. And the subjects here were only, each subject was only asked once. I wouldn't want to do it 3 times because then they'd figure out, oh, it's just a game.
Right.
That'd wreck the whole thing. So this is 1 independent variable, or what's the other term for variable that we often use? This is a 1 factor. So this is a one factor or one-way ANOVA, one independent variable, 3 levels. Now, if I just asked you to look at the data up there, does it look like from the data, if I asked you to kind of eyeball it and just get some sort of estimate, does it look like the experiment worked if you just use information from the case study? Does it look like it worked, Beverly? Does it look like it worked if you just look at the numbers in the case study?
It looks like it.
Why do you say that? What do you use to make that decision?
Like their scores, like, you can tell that there's like a really, it seems like a big difference between the scores from the bump versus the smash.
That's right.
Group.
The smash group, the mean, the key thing you'd want to use is the measure of central tendency. Get the mean. It's pretty easy here, isn't it? What's the mean for contact?
29.
29. What's the mean for bumped?
32.
32. And what's the mean for smashed?
51.
So I make it pretty easy on the test. It'll be the same way, and you won't have to do a one-factor ANOVA by hand, but you just look at the 3 numbers. These 3 numbers, do you think they're going to go into the numerator or the denominator? It's going to be the numerator. This is kind of the treatment effect. You could actually almost figure it out in a way. The mean of the first group, x bar 1 is 29, x bar 2 is 32, x bar 3 is 51. You could get a grand mean, subtract things, square them, but we're not going to do any of that anymore. But you could kind of see the 3 means are kind of different here. And that's probably going to be a good thing. So that's positive. How about the denominator? Could you kind of get an eyeball on the denominator? Is it good news that we have 27, 29, and 31? Are those numbers pretty close together, Emily?
Made contact and bumped are close together, but smashed is pretty far.
But those are the mean differences within the group. How are the numbers within each of the 3 groups? Within made contact. Remember the bars where you look at within group? Are they pretty close? 27, yes. 20, yeah. Within group, the dispersion is kind of small. That's going to lead to a small variance within group. Hopefully you can see that. Just eyeballing it, that's an important thing. So we can actually do this on the computer. Let's see, is it a good time to stop this? Yeah.